Here we go. All right, so we left off. We were talking about, we were going to do this exercise 6 where we've got hydrogen cyanide. It's a weak acid. They gave us the Ka value here. And if we have a 50 ml sample of 0.1 molar HCN, and we're titrating that in with NaOH, 0.1 molar, they're asking what's happened after 8 mils of this has been added. Okay, so at this point, we have our 50 ml sample of this. We have a Ka value. We're trying to figure out what? pH. So we're going to figure out our H plus concentration. And that's going to equal our Ka, which they gave us here. Okay. So they gave us the Ka. And then we've got our, got to figure out our molarity here. So we've got to figure out moles of this. So moles of this, we're going to have to take this and make it into liters, which is 0.05. So 0.05 times 0.1 is what? Okay. And is that going to go on the top line or the bottom line? On the top line. So 0.005. We're adding in NaOH. So are we going to subtract this, the moles here, or are we going to add the moles on the top line? I got an add, I got to subtract.
Add.
Remember, the top line is for acid.
Oh, it's a base.
Yep.
Oh,
NaOH, I believe, is a base. You should have that memorized.
No, I didn't see what.
Okay. We're starting out with 0 base, so we're going to add down here. Now we've got to multiply these together to figure out what that's going to be. This is going to be 0.008 times 0.1, which ends up being 8 times 10 to the minus 4. 8 times 10 to the minus 4. All right. I don't need to do this math for you, I don't believe, right? You guys are solid enough to be able to do that on your own.
Oh my God. Struggle with that.
What?
Ellie says.
We're tired of math. Shut up. Ellie does.
I'm confused. I don't know what she said. I still don't understand.
She said. What did you say? You're not in this class, Matt. You can't speak for. Oh, okay.
Oh, okay. All right. That's your little petty arguments. Okay. So I'm going to take this and I'm going to subtract. I'm going to add. I'm going to divide. I'm going to multiply. When I do all of that, you should come out with a value that is equal to 3.25 times 10 to the minus 9. So what do I need to do with that?
Negative log.
Negative log will then give me my pens. Negative log will then give me my 8.49. Good?
Yes.
All right. Now, the next one should be very easy for you to do, because at the halfway point of the titration, the pH equals what?
PKA.
pKa. So if I know my pKa, my Ka, all I have to do is go negative log of the Ka, and that gives me my pKa, which then will equal my pH. Do you see why we didn't bother to give you much room there?
Yeah.
Okay. So that is going to equal 9.21. All right, now we get to the fun stuff.
But it's 7.
No. All right, it's not strong to strong. Okay. So, yeah, go ahead and make a guess.
7.
No.
Say like 10, 11.
9.8.
You've got a weak acid plus a strong base.
13.7.
So you know the pH is going to be
Above 7.
Greater than 7, right.
I say
Okay.
15.
So let's find out. All right, so we've got our equilibrium point here. So our Cn minus plus our H2O, because remember we had our, okay, so let me back up. At the equivalence point, we would have our HCN coming in with the NaOH. That's going to make, NaCN plus H2O. Okay. So then, hence, that is enough. This is complicated enough. I'm going to get rid of these. I'm going to get rid of these so that it's easier to see what's happening here. This is a minus. This is a minus. Okay. So now this CN that's left over from here, and how much have we made? Well, we started with 0.05 moles here. So we've made 0.05 moles of this. Does that make sense? Now we've got to see what that's going to do to this water, because it's going to set up an equilibrium situation here where we're forming some HCN plus some OH minus. Yep. Okay. So we've got to see what that value is going to be. So here we've got 0.05. I got that from right here. I'm bringing that over. We don't care about the water. We're going to be making X here, and here we're going to be making 0.05 minus X. Okay. We can easily ignore this X. We just need to document it. Okay. And now this hens move. That's the next option. If I have to say that word again, one of you is moving. Do you understand me?
Allie's the problem. It's Evie.
Then you'll both move.
I was listening.
All right. Right here. What is this?
That is going to be your concentration of pOH.
That is my OH. Okay. If I've got OH here, when I do my K value here, what does this have to be? KB. Okay. So this has to be a KB. But they didn't give me a KB. They gave me a KA. So to find KB,
you take KA divide, no, 10 to the negative 14 divided by the KA. No, I'm sorry, I'm smarter than you, Lily. Shut up.
okay? So I'm going to take my 1 times 10 to the negative 14. I'm going to divide it by my KA, which we saw up here was, no, 6.2 times 10 to the negative 10. So now I'm going to find my KB. So my KB is what I need here. That KB then is going to be equal to 1.61 times 10 to the minus 5 equals what?
Negative log it, right?
Nope.
Equal to
I've got a nice table over here.
X squared over 0.5.
X squared over 0.05. So then I multiply by 0.05, then I take the square root, and I'm going to find that X equals 8.98 times 10 to the minus 4. What is that?
concentration of
pOH.
Concentration of
Right, that's my molarity of OH minus. So if I take the negative log of that, I'm going to get what? pOH. So negative log of this value is my pOH, which is 3.05. And then if I subtract that value from 14, that's going to give me my pH, which is 10.95. We said that our pH should be greater than 7, and it is. Okay. All right. We have ammonia here. We're doing ammonia, which is a weak base, with hydrochloric acid, which is a strong acid. Okay. We want to try to figure out what we're going to use, what indicator we're going to use to make this work. Okay. So if we kind of, just kind of guess here, and this is just a complete guess. Okay. Where would your pH most likely be? Right. It's going to be above 7.
Below 7?
Below 7. I'm sorry. Below 7. It's going to be below 7. So probably in that 5 to 6.5-ish range. I'm not sure. Do I have the Ka values of ammonia? Let me look up the Ka value of ammonia. Okay. Ka of ammonia.
Is it your basketball player?
Okay, the Ka of ammonia is
Your mask is on.
all right. So does that make sense that it's going to be somewhere in this range? So then if we look back at our indicators, we need to find, did I have indicators in this section? I don't remember. No, I don't. That's a different set of notes. Was that my titration notes?
Lily, can you grab me whatever that other thing is?
It's chocolate.
Is it dark chocolate?
It's like a chocolate covered brownie. It's good.
It's good.
I split that perfectly down the middle.
You did. I watched you do that.
I'm great at doing this.
I don't remember if this is where it's at or not.
You know we're gonna go to that Goodwill, then we're gonna go and do all of that.
Okay, apparently not in that document.
When we were doing it, I didn't know what we were doing it.
Yeah, please put your
mask up.
Here it is. Okay. So if we're in the 5, we don't know exactly where it's at, but this one right here, this methyl orange, do you see how that has a good long span here? That's going to give us a good section in that range, because it's going to, it goes from 3 all the way to like 6.5. So I would go with methyl orange for that, or the thing said methyl red too. So they also liked methyl red for it as well. So either one of those, there's a lot to choose from here in that range.
Actually, that's orange.
Are you making fun of the way I say orange?
No, I'm just writing math.
I said
Okay.
I chose that.
People make fun of the way I say orange sometimes.
Yeah, look, you think we could make
Can we make
for a
meth
lab?
for a lab?
Did you say meth?
Yeah, like crystal meth.
No, this is not Breaking Bad. No.
I've never watched
Lippy,
that.
is that thing used to exploding meth lab?
Then why did you laugh? You were like,
No, we're not gonna, no, we're not doing this. Okay.
We can look up them.
Bromothiamyl blue. Hi.
Hi, guys.
Speaking of
Allie,
meth.
Allie,
Sorry, Allie.
make people feel bad.
They were just asking me if we could make meth.
Oh, yeah.
No.
That's not what this is.
This
Off
flipping
the record.
cat sells meth out of her car.
No, she does not, and we're recording this, by the way. So let's not start small rumors here.
They think we're learning chemistry. We're just making meth.
We are not. No.
It's just a secret.
this. We've got a Ka value of 1 times 10 to the negative 7. It's yellow with the hydrogen or the protonated form. They like to call that protonated sometimes. And blue when the hydrogen is gone. Suppose we put a few drops of this indicator in a strongly acidic solution. If the solution is then titrated with sodium hydroxide, what will the pH color, what pH will the indicator color change first start to be visible? Well, remember, we can take this and we know that our pKa is what? 7. And typically, I got choked last hour and I can't get it out.
Who choked you?
No,
Yeah,
like,
who choked you? What? No, yeah, I heard from the guy's like, hey.
all right, so when
You just got her.
when we do this, typically your form here, the changes will happen at plus or minus 1. So you'll start to see a color change at plus or minus 1. So there'll be a color rate change between what? 6 to 8. So since this started out being acidic, it's going to be 6 that's first going to occur at.
What pH? pH is 6?
Yeah.
No more math.
Any more math?
All right. We're going to talk about this section now. I've tried to guys.
This is all Allie's fault.
I tried to modify this form so that it accepts the way I do this. Okay. So I also put this Henderson-Hasselbalch equation on here because that's what's on your blue sheet. Are you filming this?
I'm filming Lily. You didn't listen. Are you filming?
Yes, we're filming.
I need you to pay attention to this stuff, okay?
We're focusing now.
This is the equation that I use, and this is a good kind of visual so that you can see the two together, see how you have to alter this to make mine work. But again, mine's much easier to work with because we add and subtract in moles. Okay? But that gets rid of the plus in here. So everything's divided or multiplied, okay? So strong acid, strong base. When you're doing these, you're making water and a salt. To prove this type of problem, follow the steps. Find the moles of the acid, moles of the base. All the limiting reagent will react. Find the amount of excess left over once you're neutralized. Larger moles minus smaller. Divide by the moles. This is a stoic problem. Strong, you're in the land of stoic. Remember your strong acids and your strong bases, and I've given you a little mnemonic there if you need it.
What is it? So I bought no clean clothes.
Oh.
Oh.
I think it goes together well.
How do you buy dirty clothes?
All right, so weak acid and strong base. We've talked about this. You're going to use your ICE table then. Use your Ka or Kb if it's an OH and determine it. And then you've got your weak acid, strong base. We've done some examples like that already. So
Oh my gosh, this is why we can't give Lily like crack on it or something.
Yeah, there's.
No, meth, Lila.
Not crack. You
Come
hope
on.
you don't crack.
all right.
You're at your mom's today.
So we have 100 mils of 0.1 molar acetic acid. So that's going to be 0.01, right? Is that right? Yeah, 0.01 moles of this. And it's added to 0.01 moles here
Of a strong.
with a strong base. Okay?
We have to do ice tables.
Toy.
No, ice tables, because it's not strong as strong, so you can't use. I would not be surprised. Caitlin does that to me all the time. No,
Maybe that would kill
no,
the
she has
light.
it so bad.
It was so bad. I was like, blew it all over me. And like,
It's disgusting.
Are we supposed to be doing this right now?
I'm trying, but I can't think because they're talking way too much for my brain to be able to deal with this.
Well, there's
So.
a life in
All right. So when I have this going on, okay, I'm going to take my 0.01 moles of acetic acid. I'm going to divide it by my 0.2 liters. That's going to give me my molarity of my HA. Okay. So that's going to give me 0.05 molarity. So then if I have my HA plus H2O, that's going to give me, or no, this would be my A minus, I'm sorry.
No.
Oh my gosh,
It'd be
what is
HA.
that?
No, it'd be A minus, you're right.
Oh my god, I can't breathe. My nose is burned. If you had your mask on, we wouldn't have this issue.
I'm honestly used to it.
Oh my god.
Not allergies.
I'm so sorry.
Ladies, why don't one of you move, please?
Allie, I was focusing.
All right, this is HA then plus what?
OH minus.
OH minus. Okay. So then we just figured over here what our molarity was going to be of this guy. So he's going to be 0.05. We're going to minus X here. We're going to plus X here and plus X here. Yes. So 0.05 minus X, and we're going to ignore. We just need to document that. Okay. Now, this guy is OH. So we need to find KB. We have KA, we need KB. So 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5. That gives me a KB value of 5.56 times 10 to the minus 10. Okay. So, then my KB is going to be equal, so 5.56 times 10 to the minus 10 equals X squared over 0.05. Multiply both sides by 0.05 and then take the square root, and I get X equal to and what is that? What units? Right, this is my molarity of OH minus. So then I need to take the negative log of this. When I do that, it gives me the POH. My POH then is 5.28. And that makes my pH
8.272.
okay? And does that make sense? We're taking a weak acid with a strong base, our pH at the equal at that point then should be
Above 7.
right. We're at the equilibrium point because we're equal moles of each. So we know it should be above 7. All right. pH of a solution then here is composed of 500 mils of sodium hydroxide and 400 mils of 0.2 hydrochloric. They want to know what the pH is. We are in the land of stoic. We have a strong base and a strong acid. So I need to find my moles of each of these. Multiply these together. So this is going to be 0.125. And this guy will be 0.08. Okay. Which one do we have more of? Okay. So we're going to take our moles of our base and subtract out the moles of the acid. That's going to give us moles of the base. And then what do we need to do?
You have to add the liters together and convert it to molarity.
Okay, so I'm going to add my liters together. So this is going to be 0.9 liters. That ends up being 0.05 molar OH minus. What am I going to do? Negative log gives me POH, which equals 1.3, which means my pH equals 12.7. And you've now gotten through the worst thing in AP
This is
chemistry.
actually the worst. I didn't think it was.
You know what, Matthew?
Just because it's that hard for you doesn't mean it's
All right.
hard for others.
Tomorrow we have a lab. I'm going to pass that lab out. It is my great expectation that you read that lab before you come in here and you know what you're going to do when you get in here to do the lab. Okay? Make sense?
Water from across the hall.
So
Water
it's-
from
it's-
across the
it's-
hall?
Yeah.
Oh, yeah.
So it's
Zero to one
8:40 tomorrow. 8:40 tomorrow, right?
Yes.